Hi, Chris Good here with another video for you guys, and in this one I'm going to be solving one of the t-test problems that I distributed to you guys in class on Monday, January 30th. This one is problem number 1, and this is the study about differences between older and younger adults on perceived life satisfaction. A pilot study was conducted to examine the hypothesis. 10 older adults and 10 younger adults were given a life satisfaction test known to have high reliability and validity. Scores range from 0 to 60. Higher scores mean higher life satisfaction, lower scores, lower life satisfaction. Compute the appropriate t-test. Well, I'm going to do my steps in order. First, of course, state the null hypothesis. I can see that these are two different groups of different people, obviously, because some are older and some are younger. So I'm going to be using an independent samples or independent measures t-test. The null hypothesis of which is that the difference between the two population means is 0. Step number 2 is to to look up the critical value for t. As always, I'm going to use an alpha of 0.05. In the future, we may decide to change that for a different problem, but here, still alpha of 0.05, and our critical value for t is going to be determined by the degrees of freedom. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores for older adults, 10 scores for younger adults, and 1 is equal to 10, and 2 is equal to 10. The total degrees of freedom then are N1 minus 1 plus N2 minus 1, or 9 plus 9, or 18. Now that I've got my degrees of freedom, the critical value for t for 18 degrees of freedom, right? I'll just look up my handy t-table right here, and I can see that for two tails combined, right, 18 degrees of freedom, that's 2.101. Alright, 2.101. Step 3 is to calculate the statistic. Well, we know that t for the independent samples t-test, independent measures t-test, is mean 1 minus mean 2, minus our hypothetical population mean difference that we know to be 0, divided by the estimated standard error of the difference between these two means. So what remains is to compute that, the estimated standard error of the difference between the two means. For the independent measures t-test is equal to the square root of the pooled variance over N1 plus the pooled variance over N2. Well, pooled variance then, right, is equal to the sum of squares for 1 plus sum of squares for 2 over the degrees of freedom, 1 plus degrees of freedom 2. That's the total degrees of freedom. Sum of squares then we have to do for each group, and it's equal to the sum of x squared minus the square of the sum of x. Remember, these are two different quantities. And we'll do it for N1 for the first group first. I'm going to write out all my squares of the scores off to the left-hand side this time. So 45 squared is 2025. 38 squared is 1444. For these big numbers, keeping track of them, I think, is the hardest part. So it's good to write them down in an order and in a place that makes sense and to be consistent across all the problems that you end up solving. Okay, so I'm about halfway here. 1521, 2601, 2116, and check, don't always trust your calculator. Make sure that these are in the right ballpark. These should make sense to you. All right. I'm going to sum up all of these squared values, so I'm going to go backwards up this way. 2116 plus 3025, 2116, 2601, 1521, 6, oops, I need to go back, 5, plus 620, that'll make it all work out, 2304, 2704, should slow down here, 444, and 2025 is, so I get a total of 20481. Now I'm going to add up all the scores. 45, 38, 52, 48, 25, 39, 51, 46, 55, and 46. I get 445. Square that. We have 10 total scores. So that's 20481 minus 198025. Sorry about the handwriting. Over 10. So you divide that by 10, right? You subtract 20481. I end up with 678.5 for my sum of squares for group number 1. Let's do group number 2. That's the sum of the squared scores in group 2 minus the sum of all the scores in group 2, and you square that value divided by the number of scores. Again, I'm going to write them out to the left. 34 squared, 22, 15 is 225, If you can do it with these big numbers, you should be able to do this kind of t-test with just about any numbers at all. Okay, I'm going to add these back up. 676, 361, 576, 1681, 1369, 729, 225, 484, 1156. I get a total of 8553 for the squared scores. Okay, now I'm going to add up all the regular scores. 36, I'm going up from the bottom. 26, 19, 24, 41, 37, 27, 15, 22, and 34 for a total of 281. And of course n is the same, 10. I'm going to square 281. This is going to be 78,961. Oh, I'm sorry, it's 8553. 8553 minus 78,961 over 10. Or 7896.1. The difference between these, then, is 656.9. Got my two values. I can go back, plug them into the pooled variance equation. 678.5 plus 656.9 over 9 plus 9. These are degrees of freedom, not n, right? That's 1335.4 over 18. 74.19 with rounding. Okay, plug my pooled variance back in up here. 74.19 divided by 10. That's the square root of 7.419 plus 7.419 and that's the square root of 14.838 or 3.85. Alright. Now I need to calculate our means. You know, I already got the totals here and here. The mean's just going to be each one of these numbers, right, because that's sum of x, right? Not sum of x squared. This is the sum of x. So sum of x for group number 1 is 445. Sum of x for number 2 is 281. So the mean here is 44.5. The mean here is 28.1. And we just calculated our estimated standard error, 3.85. So 44.5 minus 28.1 is 16.4. This was 0, right? 16.4 over 3.85 is 4.26. Let's compare that with our critical value for t. I can draw a tiny little t distribution right here and shade that region just for fun. That's negative 2.101, positive 2.101. I'll shade these regions just so I can be sure that this 4.26 is out here in the critical region. So step number 4, we're going to reject that null. And now I need to write some kind of conclusion, right? We rejected the null. What does that mean here? The null was that there's no difference between older adults and younger adults. We rejected that idea. I'm going to write a little sentence about what we can say about these data. So we can say that older adults they don't show anything. They have something. They have significantly greater life satisfaction. Greater, so I said the direction of the effect. Than whom? Than younger adults. And I'm going to actually put my statistic in APA style into the sentence here. T with 18 degrees of freedom is equal to 4.26. And the p, we know that the probability associated with this is less than alpha, so p is less than 0.05. That's all we can say at this point. If we had a computer, it would tell us exactly what p was. All we know is that it's less than 0.05. What's different about this study than many of the other ones that we've looked at is that this is not a true experiment. Obviously, you can't randomly assign someone to be older or younger. That's a subject variable. We call this a quasi-experiment. It's not a true experimental design, and so you can't say anything about cause and effect. Being old doesn't cause you to have greater life satisfaction than being young. Being young doesn't cause you to be less satisfied. All you can say is that there is a significant difference between these groups, and we'll leave the conclusion at that.